What I'd like for you to do is to try these two. And that's what I'm going to do. I'm going to pause again. I'm going to try these two, and I'll come back and show you my work and the answers. Here's number 3. I found my P's and my Q's, and I did P divided by Q. I didn't get lucky on this one. I guessed once. I guessed -1, and that was not correct. But my second try was good. I got 7. 7 gave me a remainder of 0. Then I knew I was going to run out of space, so I went to this piece of paper and I used my new function. Remember that new function comes from here, x cubed because you subtract 1 from this, x to the 4th divided by x cubed plus 7x squared plus x plus 7. And that's where this came from, x cubed plus 7x squared plus x plus 7. I found my P divided by Q again. And I didn't think about this till I was almost done, but I got to remember that I've already used +7. So really I have 3 choices, and of course I didn't pick the correct one until the last one. I guessed -1 and that didn't work. I guessed +1 and that didn't work. And I guessed, or I didn't guess, I knew it was going to be -7, but I just wanted to work it out. So I put -7 and it gave me a remainder of 0. Then I took this quotient, which would be x cubed divided by x, which is where x squared came from, plus 0x plus 1. Since b was 0, I decided to solve using square roots. I took this function, set it equal to 0, subtracted 1 from both sides. I got x squared equals -1. Took the square root, so I got x equals plus or minus I. So my 4 solutions, remember according to the fundamental theorem of algebra, I would have 4 solutions. And those 4 solutions are +7, -7, positive I, and negative I. Now I'll go on to number 4. For question 4, I'm not very fond of this one yet. We'll see. I'm sure that some of these fractions are going to be part of the answer. But my P's are +or-1, +or-2, +or-4. My Q's are +or-1 and +or-5. How did I find P divided by Q? I did +or-1 divided by +or-1. That's this. +or-1 divided by +or-5. That's this. +or-2 divided by +or-1. That's this. +or-2 divided by +or-5, +or-2 fifths. +or-4 divided by +or-1, +or-4, +or-4 divided by +or-5, +or-4 fifths. So next I'll go try to figure out, hopefully I'll guess correctly on the first try, we'll see. I could not believe it. I wanted to immediately come and show you. As I was sitting here looking at these 2, 4, 6, 8, 10, 12 choices, I thought, I don't know which one I'm going to choose, but I will go for a fraction. So I chose -1/5. And look, I got 0. Let me go through it with you so I can show you how I got all these numbers. I brought down the first one. -1/5 times -5 would be +5 fifths, which is 1. 9 plus 1 is 10. -1/5 times 10 would be -10 fifths, which is -10 divided by 5 is -2. -18 plus -2 is -20. -20 times -1/5 would be +20 fifths. 20 divided by 5 is 4. When I add them together, I get 0. So I found it on the first try. I cannot believe that. Okay, so I found all the solutions, or the answers. -1/5, 1 plus I squared of 3, and 1 minus I squared of 3. Let me go through the process. So the last thing I showed you was this. And I turned that into a new function, h of x equals -5x squared plus 10x minus 20. Once you're down to a quadratic, you can solve that quadratic using any method you want. You can try to solve by factoring. This one would not solve by factoring. You could complete the square. You could do the quadratic formula. I just think the quadratic formula is faster. I don't mind completing the square, but I just think the quadratic formula is faster. So the first thing I did was replace h of x with 0, And then I noticed they all had a common factor of -5. Even if they all hadn't had a common factor of -5, I would have taken out a negative so that my A would be positive. Then once I took out my common factor of -5, I did the zero product property. I set both of those factors equal to 0. I threw this one out because -5 can never equal to 0. It can never be 0. Then I solved this by using the discriminant first, using the quadratic formula, b squared minus 4 times a times c. Then I got -12 for my discriminant. That means I'm going to have 2 complex, which means I'll have an I in my answer. Then I filled in the quadratic formula, -b plus or minus b squared minus 4ac under the square root over 2 times a. Then this radical broke down into these, square root of -1, square root of 4, square root of 3, and that turned into 2i squared of 3. And then these 3 numbers are all divisible by 2, and so that's how I came up with 1 plus I squared of 3, 1 minus I squared of 3. I think the next video, I hope that I have enough time, the next video I'll show us how to write these functions.